Coming up on Extra Credit, we meet a Drupal developer who shows us how code is used to create interactive websites, learn a song to help us remember mean, median, and mode, and an NBA superstar explains the importance of tech-related careers. Stay tuned. Welcome to Extra Credit, where we meet interesting people, explore new ideas, and discover fun places together. I'm your host, Kenneth, and it's a beautiful day for some Extra Credit. Ever wonder how a computer knows what to do even if it can't understand our language? In our first segment, a Drupal developer from Commercial Progression will talk to us about how she uses her programming language to create all sorts of different websites.
Hi, it's Jenilyn, and today I'm here with Miss Hillary Lewandowski. So, Miss Hillary, where are we today?
Today we are here at Commercial Progression in Northville, Michigan. I'm called a Drupal developer, so I do a lot of coding or programming. Coding is how humans talk to computers. So I write in a language that a computer can understand and tell it what I want it to do. It's just like learning another human language. You just learn how to communicate with someone else. Drupal is what's called a content management system. It's a piece of software you can install it and you get a working website. A lot of people can't catch on to Drupal very easily, and it's very hard to learn, and that's where I come in. I really love making something great for a client. When I've made a good website and they come and say, this is an amazing website, that's when my job is worth it.
I had a great time meeting Miss Hillary today and learning all about website design. Explore your possibilities.
Do you have a vision? It could be anything between saving the world and making a three-point shot. In our next segment, one of the biggest names in all of basketball explains how your vision can help in a career of tech.
My name is Stephen Curry, and I play point guard for the Golden State Warriors. The value in learning computer science is pretty evident just with how important tech is in our world.
Kel,
Yes.
nice to meet you.
Nice to meet you,
Stephen, pleasure. Okay.
Here we have the Play the Fruit Salad Piano.
Play the fruit salad. Okay.
Click any one of these fruits.
Just touch the fruit?
Yes.
Just any one of them?
I mean, the opportunities are endless for somebody who's getting into computer science because that's a job that's in high demand right now.
Drag
Over
it.
there.
Right in the space?
Yes.
If you want to create and you want to be a visionary and type, you're probably going to be in tech space trying to do that.
There it is.
It's extremely important to have perseverance when you're learning new skills because anything that's worth doing usually doesn't come easy, and knowing that in the end it will pay off.
Oh, that's it right there. No, I'm an amateur coder. I don't choose.
It was a cool experience to kind of get in front of the computer and test my skills a little bit.
See if you're
No
worth it.
way. Did I just code a line? Come on, dinosaur. Thank you, thank you.
Go beyond the hour of code. Pledge to bring computer science to your school.
Artificial intelligence, also known as AI, is all around us. The most common form of AI is called machine learning, and I bet you interact with it every day. Here's more about machine learning and how it's changing our world.
My name is Ale Flores, and I'm a product manager at Alexa.
My name is Dr. Chelsea Haupt. I work at the Allen Institute for Artificial Intelligence, and I work on an AI-powered academic search engine. All around you, computers are making decisions, and those decisions affect your daily life. When you do an internet search or scroll through your newsfeed, computers decide what you see. Computers can already recognize your face and understand your voice. And soon they'll be driving cars and detecting diseases even better than humans. So how is any of this possible?
You may have heard about something called AI, or artificial intelligence. True artificial intelligence is decades away, but there's a type of AI called machine learning that is here today. It's a type of AI you probably interact with every day without even knowing it. and it has the opportunity to help us tackle some of the world's biggest challenges.
Machine learning is how computers recognize patterns and make decisions without being explicitly programmed. What's so exciting is that it's a completely different way to program a computer than what we've ever done before. With machine learning, instead of programming a computer step by step, you can program a computer to learn just like you learn, through trial and error and lots of practice.
Learning comes from experience, and that's true for machine learning too. In this case, experience means lots and lots of data. Machine learning can take in any kind of data, images, video, audio, or text, and begin to recognize patterns in that data. Once it learns to recognize patterns in the data, it can also learn to make predictions based on those patterns, like noticing the difference between an image of a car and an image of a bicycle.
AI and machine learning are playing a bigger and bigger role in society at large and shaping all of our futures. That's why it's so important to learn how it works with some hands-on experience. You're about to get the chance to train your own machine learning model. Remember, AI is like any tool. First you get the knowledge, then you get the power.
Welcome back. Guess what we're doing today? We're going to continue learning about magnets. That's right. And right here, I have one of the coolest things that I've ever built with a magnet. It's a levitating, well, it's a floating, spinning, battery-powered pencil? Look at that. That's so cool. And the thing is it's battery-powered, but the batteries aren't connected to anything. So how is it working and how is it spinning? Well, it's really easy. This here has a magnet on top of it, and that magnet is attracted to that magnet. In fact, they are set up so that they have opposite poles looking at one another or facing one another. Those opposite poles are attracted to one another. The magnetic field sitting right there allows this to actually spin. Both magnetic fields are interacting, and it's causing this pencil to be able to stand up straight. We can look at that a little bit differently also if we look at a traditional bar magnet. This is a bar magnet. It has a north pole and a south pole. Magnets have two poles. And what's really cool, if I were to snap this in half, it would create a new north and a south pole automatically. And we can use these two bar magnets to look and see how these magnets behave. So I have a red side, which is the north, looking at the blue side. And what happens is when I bring those two together, the opposites are attracted to one another. When I bring the like poles together, it pushes it away. Now, it doesn't slide very well because of friction. Good thing I have these little magnets with little wheels on them. So check this out. Let's move some of this out of the way. Here I have two little race cars. I have the north end and the south end. When I bring those two together, they pull together, opposites attract. When I bring the like poles together, likes repel. And we can see that again. That's super cool. So we can use this idea of magnets to have some fun. And one of the things is, like I said before, magnets produce a magnetic field. Even though it's invisible, like we saw with this, even though it's invisible, whoops. That's why I have my notebook set up. So I gave it a little bit of extra space. There we go. The magnetic field is invisible, but the magnetic field allows us to still put things through. Like that's paper, here is wood, sort of like a pencil. Then I have this pipette. Look at that. It doesn't disrupt the magnetic field. It continues to work. But if I take something like iron, it disrupted the magnetic field, but not enough, and this kept standing up. That was really cool. So what's really neat is this magnetic field, although invisible, is there. And we can actually use this to do some art. And you're like, what? Artwork with magnets? Absolutely. One, you can build a sculpture. Let's see here, we got 2 iron nails, a steel washer. There we go. See how high we can make that. So we got iron nails, steel washer. And steel actually has iron in it. And then if we want to, we can build like little arms coming off. Maybe. Depends on how strong this is. Oops. Oh. All right, it's kind of a sad looking sculpture. He's like, hello people, hello scientists of the world. Oh, he's feeling really smart. Look at that, he's like, what's up? You ready to do some more art with science? Yes, please. All right, so you can build a sculpture using magnets, which is really cool and fun. Or you can use some iron filings. Now, iron, nickel, cobalt, those things are all attracted to magnets. All right, so I have these iron filings in it, and I'm spraying them all over the place. What you want to do is you're going to need a couple of things to do this. You're going to need some blank paper. You're going to need a Sharpie. And I have this protective sleeve where you put paper in it, some tape. And you don't have to have this, but I have a clipboard, and I'll show you why I'm going to use it. What we're going to do first is we are going to dump a whole bunch of iron filings into our bag. That might be too much. All right, that'll work. And what we're going to do then is we're going to take a piece of tape. I have owl tape. Who would have thought? We're going to take some tape. I'm going to make it about 8.5 inches long, which is the width of this. I'm just going to put this over the edge so that it doesn't have iron filings flying out all over my house. And then I'm going to close it off. Perfect. Now that's sealed, and I have these iron filings in here. Now, we said it before, magnets have a magnetic field. So when I put this here, I should be able to move iron filings. Now some of you might be wondering, how is this art? Well, here's the next step. You're gonna take some paper, and you're gonna try to draw either your face or a family member's face or a friend's face, but without any facial hair. So just eyes, nose, shape of a head, and a mouth. So here we go. Let's give it a try. I wonder if I should put the eyes on there. Make some teeth. I need my ears. I am gonna put eyes because it looks, and I'm gonna make ta-da! It looks just like me, doesn't it? But I'm missing hair, I'm missing my mustache. And you might be wondering, well, what's gonna happen here? Well, this is where the art comes in. We're gonna take what we just learned about magnets. We know that magnets are attracted to iron. We have a whole bunch of iron filings. We're gonna take our protector sheet. Uh-oh, I have a hole in it. Oh, all right, so make sure that the one you have doesn't have a hole in it. Just gonna take a little piece of tape, cover this up. Oh, I can't believe I have a hole in there. That's all right. See? Totally fixed. All right, so we have iron filings all over the place. Let's set that up again. So what we're gonna do now is we're gonna take our protector, put it over our face, just like this. And I'm gonna use the little clipboard to hold it in place. The reason I'm gonna use the clipboard to hold it in place is just so that when I have it on the table, I can move things really easy, and it'll keep kind of everything connected. And now what you do is you take a magnet. It can be a circle magnet. It can be a bar magnet. Whatever you have at the house. If you have a refrigerator or magnet, it should do the trick as well. And then I'm going to take iron filings and I'm going to move them on top of the drawing to design my character. So let's give it a try. All right, looking good. I know I need some eyebrows. All right, so I'm gonna use this bar magnet also because it has a more narrow tip. It's kind of more pointed. I'm hoping I'll be able to move less. Yes, it's not reacting with. Oh, look at that. Look at my eyebrow. I'm gonna move that out of the way. Oh, that's awesome. So I'm gonna use this magnet to move it up because it moves a lot better. It's stronger. And then I'm gonna use this. All right, kind of heavy on the eyebrow, just a little bit, but I'm okay with that. I'm okay with that right now. All right, and then I'm gonna pull. I need a mustache. I'm gonna loosen this away. All right, now I gotta straighten that. Oh, look at that! I need a little bit of a goatee. This out of the way now. Get as much weight off the face as I can. Oh my goodness. That is spectacular magnetic art. I've got a little bit of work to do. So, I'm gonna encourage all of you to have some fun doing your art. He looks so mad. He's like, oh, why'd you make me look like that, Mr. C? I don't have spiky hair, but what I think I need to do is I think I need to make the drawing smaller so that I can work with the hair and make it more wild. But that's the cool thing about this. When you're done, I hate to get rid of this. I hate to get rid of it, but when you're done, all you have to do is this. And you start over. You have a blank slate to work with. It's like art that never ends. Oh, that is so much fun. You have to give this a try. You have to let us know if you love doing this. Encourage your friends and family to do it with you. This is so much fun. All right, we've got more videos on the way. Take care. It's all about getting smarter. All right, bye guys.
In our next segment, a robotics and automation educator shows us the new career opportunities available by learning how to program robots in manufacturing and automation.
Hi, it's Jenilyn, and today I'm here with Professor Sid Mosley. So, where are we today?
We are at Lansing Community College, and this is the West Campus at the Technology Center. Here we actually do the robotics and automation systems. Robotics basically pick up parts and they place it in another place. Automation is actually equipment that work by themselves and they're programmed to actually do a particular function. When you put them together, they actually manufacture and assemble parts. So robotics, you use a teach pendant to actually program the robot. So you're actually texting things into the robot and you're teaching the robot how to work.
Whoa, that's really cool.
I help students really understand what robotics and automation is and how to maintain these systems.
I had a great time meeting Professor Mosley today and learning all about robotics and automation. Explore your possibilities.
Picking things up with your hand is cool, but doing it with a mechanical hand is awesome. In our next segment, a mechanical engineer shows us how we can make mechanical hands with everyday items.
Hello, my name is Camila Majid, and I am a mechanical engineer and plant manager for a global healthcare company and a member of the National Society of Black Engineers. Today's challenge is to design and build a mechanical hand with 4 fingers and a thumb that bend and straighten like a human hand. You can find the written instructions for this activity at discovere.org. I hope you are ready. As you take on this challenge, you'll see what a feat of engineering your own hands really are. So here are the materials that you need. We'll go one by one. Supplies to make the hand like cardboard or thick paper, regular or wide straws, or cardboard rolls for toilet paper or paper towels. So make sure that you go and save some of those now. Also, you will need string or yarn to use as cords to help your hand move. And also you will need glue or tape to assemble the hand and scissors. Be very careful handling the scissors. So before you start designing, take a minute to watch your hand. As you look at your fingers, you'll see that there's 3 joints that only bend and stretch in one direction. I don't think they stretch in another direction, just one. While your thumb has 2 joints. So look at my finger, well, my hand rather. So I'm gonna close it, I'm gonna open it, see my thumb, only 2 joints. Look at my fingers, I've got 3 joints on each. Did you know that there are no muscles in our fingers and thumb? Like no muscles whatsoever, none, 0, 0. To bend your fingers, muscles in our hands pull a tendon, which is like a strong string that is attached to a bone in our finger, okay? No muscles, just tendons. Now, with this background, it is time to play with your materials and brainstorm some different design ideas. So here's what you should think about. The fingers and joints on your mechanical hand. Which materials might make a good finger? Think about it. How can you create a joint for your finger that bends only in one direction? Okay, number 2, what about the tendons? Think about it. Since a tendon's job is to help your fingers bend and straighten, how might you use a piece of string to bend the fingers on your mechanical hand? Think about that. How's the string going to work? Now, number 3, how will you attach the tendon, in this case, the string, you'll use string or yarn, to one end of your joint? Here's a hint. When designing your fingers, consider using hollow materials like straws or tubes and explore how cutting little notches in your tube help it bend and straighten. So take a look at I used a paper towel. So the paper towel was this way. I cut small slits. I'm going to show you one by one, and they bend. Okay, when you are ready to test your mechanical hand, pull on the strings and see if the fingers and thumb bend. Will the fingers and thumb straighten out again when you release them? If your hand breaks or doesn't open and close properly, don't give up. And I repeat, don't give up. See if you can improve your design by making any of its weak points stronger. As a reminder, I want you to go and find the written instructions for this activity and more at discovere.org. And most importantly, have fun building your own feat of engineering. Good luck.
A fresh beat and fly bars? Could it get any better? Well, it does, because Mr. C has a song about my favorite shape, the triangle. Check it out.
Triangle, only have 3 sides. Triangle, 180 degrees inside. Triangle, so many different types. Triangle, it's time to bust a rhyme. So first, let's talk about the different sides. Equilateral, isosceles, and scalene types. When you look at them closely, almost like a different shape. It's all about the 3 sides, make no mistake. Equilateral, all sides are equal. So perfectly created, it should be illegal. When you check it out, you're like,
they all look the same. La-di-di-da-di-da, equa, that's the name of the game.
And isosceles, nice tall tree. You'll find two equal sides, but never all three. It's like a little tower with a beacon above. The third side is different, yeah, I think I said enough. Lastly, scaling a little wacky different. Each side a different length to know you're not tripping or slipping or falling, getting stuck on the shape. Scaling triangles have 3 different legs. So many types, and you need to believe that learning triangles is easy here with Mr. C. So everybody, it's time to join the flow. The chorus teaches nifty things about the triangle. Next, we really have to recognize that each has 180 degrees inside, and the sum of the angles always adds up the same. Plus their angles give them different clever names. The acute ones first, snuggly cuddly bear. Every angle less than 9 degrees, but be aware those angles may look small, but they pack the same big punch. When you add them all together, it's looking pretty tough. Obtuse, the one angle's fairly large, greater than 90 degrees, thinking it's in charge. But when you realize it's part of the game, just add them up and then you'll see it's gonna be the same. Then the right, think I said enough. 190-degree angle and it's looking pretty gruff. Standing there showing off the box inside, which reminds the other triangles, it's always right. Triangle, only have 3 sides. Triangle, 180 degrees inside. Triangle, so many different types. Triangle, it's time to bust a rhyme.
Thank you all for joining me today on Extra Credit. See you again soon. I'll catch you cool cats on the other side.
This program is made possible in part by Michigan Department of Education, the State of Michigan, and by viewers like you.